So we'll begin solving a problem, analysis problem using CAD software. Here we have a cantilever structure which is loaded vertically with a force of 2 Newton at the end. The cantilever has 100 millimeter in length and 20 millimeter width and thickness 2, and we'll investigate the stress and deflection whenever you have a load of 5 millimeter at the center, and see where will be the maximum stress and deflection. Second, we'll increase that load to larger, this diameter to larger diameter, so that it reaches closer to the 20 millimeter, let's say 18 millimeter diameter, and see where will be the maximum stress, or if the stress is exceeding right here or not, or whether it's the highest stress is here. So we'll do the analysis by going through SolidWorks, and let's create the geometry first. All that we do is let's make the change here, millimeter gram seconds. Okay, so and then select top view and sketch rectangle. So we have a rectangle. Escape, give dimension for the rectangle. The width is 20 millimeter, the length is 100. Okay, and also let's put a hole at the center, circle right at the middle, when it clicks, just give that dimension. The radius is 2.5 at the center. Okay, so just this is underdefined, so you give dimension from here to here, half of it. Get dimension from here to here, not that one, yes, this one. We give dimension. Once this is a toggle, you select center, and this line, it will give you that height. Okay, so and give dimension to the hole, which is 5 millimeter. Then it will be fully defined. You can see that fully defined. Okay, and next we just told that we do select this, sketch and extrude. The thickness is 2 millimeters, so enter. Okay, we have our geometry. Save the model, save, let's create in that folder analysis cantilever W with hole, to remember. Save. Okay, now the next thing is we'll start doing analysis. To do in SolidWorks, you go to simulations and click here, put new study. Okay, you have a bunch of analysis here: static, thermal, frequency, buckling. So we'll do now static analysis. Click static and check. Okay, so now you have all this tool. We'll fix this boundary, so we will move that, select that, and then here we select fixture, fixed geometry. Okay, and then set that to be 0. It's already selected, and we fix it. Okay, you see the green check mark. The next thing is we apply load right here, as we have in the problem the load 2 Newton force. Concentrated load will apply. So then we have here external load, you force here, select at this edge, particular edge. Okay, and to change direction, now it's pointed, you can select direction like this, like this, because it's picking surface. So you have here the magnitude is 2 Newton. Select direction tool, you can use this, and then I will select this edge so that I have vertical. Okay, now this is what I want, and then I will put a check. Okay, it's uniformly distributed force 2 Newton all the edges. Okay, let's see what happens. So, and everything will be seen here. If you move around, you'll see whatever you applied. Now as you see here, there is no material is not specified, so material is not specified. So what we do is go to material, let's see, still we have okay, close first, where is it? Carbon steel, plain carbon steel. So SolidWorks has a bunch of materials, so apply materials, then you select library file. So steel, plain carbon steel, carbon fiber, silicon rubber, steel, carbon steel, plain carbon steel, annealed stainless steel are here. So let's select plain carbon steel. Here you have it here, plain carbon steel, and every property, elastic modulus, Poisson's ratio, shear, mass density, tensile strength, yield, and everything are here. So apply and close. So if you expand here, drag, you see plain carbon steel here. So it's already in the material, also color changed. Okay, then we apply this, we apply this, we apply this. Connectivity, this one is for contact points, to apply springs and other things. So that is not our concern now. All that we need to do is, here you have run this study. You create a mesh, run, create mesh, click that. So you can adjust the mesh here. For now it's coarse or fine. For now I'll leave it as it is. Okay, this is a meshed geometry. As you see, some triangulation is performed, and then just run this study. Okay, now the results will be plotted here. Stress is here. All that it is, collect the stress. As you see here, this is the original one. We have a stress of 7.4 megapascal around here, and the stress is less here. Obviously the load is applied, maximum bending moment occur here. And as you see here, around the hole there are some high stress concentrations, because this entire area is exposed to bending, and that intensity is similar experienced here, 7 megapascal. This is in pascal. So then if you see the displacement, obviously you will get large displacement at the tip. You get 1.1 e to the power of -1, which is 0.1 millimeter of deflection for that small load, 2 Newton. Carbon steel is very good, so you don't see much displacement. And here is the strain, equivalent strain, which will be maximum here, because this material will be subject to stress. So we can also animate the displacement. All that you do, right click and animate, so that this is the displacement of your cantilever beam for applied load. Okay, now we just saw that the displacement and the force, the stress are very high. Now let's go ahead and then modify the geometry. Let's say this is 20 and this is 5. Now let's make it 18 millimeter. Okay, 18 millimeter. So now we go to this is the analysis. So we'll go to our model, and let's say go to here, right click, edit, and double click the, let's say make it to 18 millimeter. Now as you can see here, you have very small gap left here and here. It's almost about to break. So let's see how much will be the stress around that area. Look at that. Now it makes sense that when you increase the diameter, at some point it will have there will be very small area left. So it's susceptible to damage right here. So, and save, then go back to your static analysis, and there will be some error because the geometry is changed. Now let's do the mesh and create mesh and run. Right click, so it will save the result. Look at this now. Yeah, so significant difference from the previous one, and this one can be seen here. Look, the material, there is no more high stress around that area, rather it is around the place where the hole, the centered hole. Maximum stress occur around here. Even look at the intensity, 3.9 is a power of 7, which is 39 megapascal of stress will be applied in this. So significant difference between the two. You can go back and revise the video, that there is significant increase. So this can kind of quickly tells you how you perform such a analysis. Let's see the displacement one. It's almost very small. Animation is same. You know, usually this is the deformation scale is 51 scale, so don't think that it is deflecting this much. This is too much. It's very exaggerated. Okay, so that's it.